Man, I really can't get those 3-pointers. What am I doing wrong?
You just gotta believe, man. Just put your wrist into it.
Students, everything can be explained by looking at the world of physics. If you want to shoot, you have to understand how it works. First, we have to assume the object behaves as particles. This will greatly assist in our calculations.
So that means we only have to consider objects as being a small and dense particle.
Exactly. The next step is to draw out the situation. Pay close attention.
When we draw out the situation, I think it's very important to write down what we know and what we don't know. This helps us organize our thoughts. So we could even separate this into our x and y components.
So we know from NBA standards that the 3-point line is approximately 6.70 meters. The vertical height of the rim is 3.05 meters, and then I'm approximately 1.80 meters. So the vertical displacement is about 1.25 meters. We also know that there's a force of gravity, so there's a negative acceleration for the y component, which is 9.8 meters per second squared. And we also know that there's no force acting on the ball in the x component, so it's 0 meters squared. But wait, we don't know the velocities or time.
All we need now is to find the velocity, and to do that, we need to observe the time. Let's head over to the gym.
So now we have our value, which is time is equal to 1.42 seconds.
We only have one missing variable, so we can use one of the big five equations to solve for the rest.
So let's start with the x component. We have our x component formula right here using the kinematic equation. We isolate for the Vx value. So as we isolate, we get this right over here. But we found that acceleration of the x is 0. So we could just cancel this part of the equation out because it will end up being 0. So now you have delta d over t. So all we have to do is just input the variables. So delta d is equal to 6.7 meters. And time is equal to 1.42 seconds. So if we solve this calculation, what we get is 4.272 meters per second.
And so doing the same for the y component, we rearrange the formula. So once again, we just input our values. Our delta y displacement was 1.25 meters, minus 1/2, and the acceleration in the y direction was negative 9.8 meters per second squared. And the time we found was 1.42 seconds. And that value is squared. And that is all over the value of time, which is 1.42 seconds. And so after we calculate this, the velocity in the y direction turned out to be 7.84 meters per second squared. Meters per second, and that is in the positive direction.
Well done. Now, if we just put these two components together in a right angle triangle like this, with the Vy being the velocity in the y direction, and Vx being velocity in the x direction, we can find the angle, which is theta, and the velocity to make the perfect shot.
So now that we have our diagram set up, we can easily find the original velocity by using the Pythagorean theorem, which is a squared plus b squared equals c squared. C in our case is the original velocity, v. So if you isolate, we get the square root of 4.72 squared plus 7.84 squared, and that just turns out to be 9.15 meters per second.
So now that we have our velocity, we need to find the angle that the basketball will be thrown at. So in order to do this, we have our two values, your x and y. We could use SOHCAHTOA and use tan is equal to opposite over adjacent. And the opposite is equal to Vy, and the adjacent is equal to Vx. So you isolate for the angle, theta, and theta is equal to tan inverse of Vy over Vx. And then we input the Vy and the Vx values, and then we get a final value of 59 degrees. So velocity comes from kinetic energy, and the formula for kinetic energy is 1/2 mv squared.
And based on NBA standards, we know that the mass of a regular basketball is 0.625 kilograms. And as we already calculated, the original velocity of the basketball was 9.15 meters per second.
So now, if we calculate for kinetic energy by inputting these values into m and velocity, we get 26.2 joules.
In conclusion, this means that the initial velocity the ball was thrown at was 9.15 meters per second at a degree of 59 above the horizontal. Now, this was created using 26.2 joules of energy.